from section 3.9, this is worksheet 3.9a. Please download this from Blackboard. Example number 2. At noon, ship A is 150 kilometers west of ship B. Ship A is sailing east at 35 kilometers per hour, and ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? The first thing I did was labeled the situation on a diagram. This is ship A, which is 150 kilometers west of ship B, starting at noon. So 4 hours later, this diagram tells us the distance between A and B from side Z of this triangle. The distance between A and where they started from, because A is heading towards this initial noon position, is going to be 150 minus x. 150 from when they started minus whatever distance is traveled, x. The distance from where they started, position, 4 hours later, is this side I'm calling y. And then this right triangle has the hypotenuse equal to z. So this picture just tells me a diagram of the situation. So let's find the 3 things in step 1. What's the given? Well, we're given that ship A, which I'm putting in the x places, and it's heading at 35 kilometers per hour. So the change in x is happening at 35 kilometers per hour. Ship B, which I'm putting in the y place, is heading north, and that's happening at 25 kilometers per hour. dy dt is 25 kilometers per hour. What's the unknown is this dz with respect to time. So this distance between the two of them that I'm calling z, dz with respect to time. And that's happening 4 hours later. Then number 3, what's the relation? Well, this is Pythagoras' theorem. So we have one side squared plus the other side squared is equal to the hypotenuse squared. A leg squared plus a leg squared is equal to the hypotenuse squared. In this specific case of Pythagoras' theorem, we have z squared is equal to 150 minus x squared plus y squared. The derivative of z squared with respect to time is 2z times dz dt. The derivative of 150 minus x all squared with respect to time is 2 times 150 minus x raised to the first times the chain rule, the derivative of the inside is minus 1, times dx dt, plus the derivative of y squared is 2y times dy dt. Step 3 is solve for the unknown and then plug in what we're given. So we're looking for the unknown, which is dz dt, so we solve for that by dividing both sides by 2z. When we do that, this 2 and the leading 2 and the leading 2 will simplify and just leave us with dz dt is equal to 1 over z times the quantity x minus 150 dx dt plus y times dy dt. So down here I made some calculations to help us figure out what z is, what x is, what y is. we were given what dx dt were and what dy dt is. So we have z is equal to, from the Pythagoras' theorem, z squared equals 150 minus x squared plus y squared if we take the square root of both sides. So x, well, ship A after 4 hours, this x position is 35 times 4, which is 140. So I put in 140. And then this y, 25 after 4 hours, is equal to 100. So I put in 100. Once again, ship A is traveling at 35 kilometers per hour for 4 hours, so it traveled a total distance of 140 kilometers. 140 kilometers distance. Ship B is 25 kilometers per hour times 4 hours, so that's 100 kilometers. 100 kilometers. When I simplify that, I get the square root of 10100. So now I just plug in all these values. X is equal to 140. And then dx dt is this 35. Plus y is 100 times dy dt, which is 25, all divided by z. And we simplify all that, we get our final answer, which is 21.4 kilometers per hour.